Okay, and somebody requested that I look at homework set 1, problem 3, how I would go about doing that, and I'll show you right now. Here we go. I just want to make sure I got the answer, the problem correctly. It is y equals c plus I0 plus G0, and also C equals Y plus, oops, 10Y, 10Y over Y plus 10. Kevin, you just entered. Were you gonna turn in your homework, Kevin, or did you need? Are you gonna ask for?
Oh, actually, yeah. I thought it was like due later in the day for some reason. Is there any way I could turn it in maybe like an hour or so?
Well, that will be during class, of course, because the class is
Yeah.
currently 12:34, and in an hour we'll be still in class. But I don't. I guess if you're still haven't turned it in, I guess I will. You can't be here right now because I'm
Oh, you're
doing all
gonna.
the answers.
Oh, I understand. Okay. All right. I'm gonna just finish it up and send it right over.
Okay, thank you.
Absolutely.
There, he left. Okay, let's do this problem. Can you guys see it okay on the screen? Great. I got some nice clear white paper here to work on instead of the lined paper. We got two equations and there are two endogenous variables. That means we're good. We can solve this. How should we solve it? Use substitution. Plug this in here for C, right? And what do you get? Maybe I should bring my computer closer so you can hear me better. You get y equals 10y over y plus 10 plus I0 G0. Right here, you're at a place where you have a y in the denominator, which is a little uncomfortable, a little harder to work with. So what I recommend when you see something like this is just multiply through by that variable in the by the term in the denominator, multiply everything by y plus 10. That'll get rid of it. On this side, you'll have a y times y plus 10. On this side, you'll have a 10y plus, I'm going to put I and g together, and then that gets multiplied by y plus 10. Why should I bother multiplying those out when they'll always be stuck together anyway? I just want to solve this for y. I think that's what you should have done. On this side, let's multiply this out and get y squared plus 10y plus everything else here. Actually, no, let's separate this. I plus GO y plus 10 I0 plus G0. Once again, I'm just distributing out these terms. Now I want to move all the y's over. Actually, I want to move everything over to the left side of this equation. It'll just look nicer if I move literally everything onto the left side, except for what will be a 0. So we have a y squared here. This 10y and this 10y, I'm going to subtract 10y from both sides. Those go away. But I will subtract this term from both sides and get minus I0 plus G0y. See, I brought that over. I also have a minus 10 I0 plus G0. All of that equals 0. I've written it this way because I want you to use the quadratic equation. I gave you that, quadratic formula. I gave you that hint in the homework, and when you write it like this, it's nice and easy. You can see something times y squared times something times y plus something equals 0. That's a quadratic equation. The solution to that is the quadratic formula, and that is y equals negative b plus or minus b squared minus 4ac over 2a, right? That's just the formula. Now let's plug it in. Y equals negative b. Well, b is negative I plus g, so it's actually positive I plus g, 0, plus or minus the square root of b squared. B squared is yeah. B is negative I plus g, so that squared is I plus g squared. Minus 4ac. A is 1. C is negative 10I plus g, so minus 4ac actually becomes plus 40I plus g. All of that over 2a. A is 1, so it's just 2. This is actually a decent answer, I think. I don't think you need to simplify it any more than this if you don't want to. Right? Um, all I'm asking you to do is, oops, I'm asking you to solve for y. Yep, I've solved for y.
So we would
Uh,
get a different answer if we just used the coefficients, because I think my only mistake was instead of my b was -1 as opposed to negative I plus
why
g.
was your, so my question is, why was your b -1? Did you divide everything by I?
So I had everything that you had up until the quadratic formula, and I think I kind of treated I plus g as kind of just like a constant or an x. So I used the coefficient in front of that, which was just -y. So I did -1, and then same for like for
You're talking
c.
about like right here?
Yeah, so my quadratic formula was it was 1 plus or minus 1 squared minus 4 times 1 times -10 all over 2. So I just didn't include that. And then I multiplied I plus g at the end. Once I got that number, I just thought we were supposed to use numbers and then multiply it out as opposed to actually having the I plus g underneath the square root.
Yeah. So actually, this is an important point that exogenous variables like I0 and G0, they should be treated just like their numbers.
Okay.
Like when you said, I didn't think you were supposed to, I thought it was supposed to be numbers. Well, treat I0 and G0 as if they're numbers because an exogenous variable is practically the same thing as a number in all of these models. It's the endogenous variables, that's Y and C. Those are the ones where you try to eliminate them until you get down to 1 and then solve for that 1. But I guess I sort of think part of the point of this was, you can't just treat. I didn't quite follow exactly what you did, but I think the quadratic equation here, it's going to have a y squared somewhere,
Mm-hmm.
and you can't ignore this. Of course, you could have divided by I plus g, and that would have gotten rid of this. But then the problem there is now you'd have a 1 over I plus g as part of your a. And so that doesn't really help. It's
Okay.
like there's no way around the fact that you're going to have these i's and g's inside of the square root sign. I
Okay.
tried to give you a hint that that's okay. Did you see my announcement?
Yeah, I followed your hint. I think it just all came down to the fact that I thought I was using coefficients, and the coefficients were supposed to include I plus g, but instead I just used either -1 or -10. So it was just the not bringing the I plus g over with
I
it.
see. Not bringing it over from this side. Is that what you're
Oh no,
saying?
I did that, but like
Oh,
once you get into the quadratic formula, you
yeah,
say y equals -b plus or minus,
yeah,
and I did y equals 1 plus or
sure.
minus. Yeah.
Yeah, so you make sure not to lose those exogenous variables. They're
Okay.
part of the answer. And then I left it as a bonus because I think it's going to be kind of hard to answer the next thing, which was find the comparative static dy dg0. You would have to you'd have to be sort of good at differentiation, and actually I think you could do it. I've taught you everything you need to know to do it. So maybe some of you did it, and I'll take a look at your answers. But um, does anybody want me to do it now, or should we just go on? What do you think? Here's my question. Did anybody feel like they got dy dg0 with some confidence?
I didn't even answer it.
Yeah. Okay. Well, it was a bonus, so you didn't. It's fine if you didn't. It's fine if you didn't. Um, you want to just talk about how you would go about doing it? You would take the derivative. So I said you can pretend like the plus version is. So forget about the minus now. And then we want to take the derivative of this with respect to g0. And that's like treating I0 as a constant, but g0 the thing that was formerly fixed as the exogenous variable is now a variable, because that's what comparative statics are. I want to see what happens when I vary the thing that was supposed to be fixed, and I compare those two static outcomes. And I always do this with my G's. I don't wrap them around enough. Okay, I'm going to do it. What the heck? The people who aren't here are still maybe working on their homeworks. So here's what I would do. dy dg0 equals. That's what I'm trying to find. I'm going to treat this as just three terms here, this, and this. The first term disappears because there's no g0 in it. It's a constant, we can ignore it. The second term is g0 over 2. The derivative of that is 1/2. I'm going to write the 1/2. And now everything else is what comes out of this big old square root thing. And that is, well, first thing I can pull the 1/2 out of this equation, right? Because it's a constant. Constant multiplied by a function, I can take the constant outside of the derivative. What I have left is this whole thing to the 1/2 power. So I'm going to use the power rule that says the derivative of something to the 1/2 power is 1/2 times that something to the negative 1/2 power. So I'll write that here. There's the 1/2 because that's the exponent of 1/2 times the thing. I just have to rewrite this thing. I0 plus G0 squared plus 40 I0 plus G0. This is hard to write. And it's raised now, instead of to the 1/2 power to the negative 1/2 power, you remember this, you reduce the exponent by 1. So 1/2 becomes negative 1/2. Am I done? No, I'm not done. What have I forgotten to do at this point? There's one more thing I need to, Amina says yes. Okay, can you show us, please? I'm showing you. What's the thing I have to take into consideration here? That should tell me I'm not done yet.
The derivative of the inside?
Yeah, that's called the chain rule. But yes, you're exactly right, Colin. I'm not done unless I also multiply it by the derivative of what's inside this parentheses. So let's do that now. The derivative I plus G0 squared is, well, I'm going to treat, once again, that as a power rule where it's 2 times I0 plus G0, right? Maybe I can get a little lower here. I have an iPhone. Oh, look at that, fancy. I have a tripod. I have my iPhone on a tripod, and I just lowered the tripod. It's low tech, but it's also high tech at the same time. Okay, 2i plus G0, that's the derivative of this first part of what's inside the parentheses. Now I want to do the derivative of the second part of what's inside the parentheses. Oh, by the way, there's like a 1 power there, right? This was squared. I reduced the exponent by 1. I'm not going to write the number 1 there, but it's implied. Okay, then the second one is just 40i plus, that's just 40. That one is just 40. So I actually think that is the answer. It's not simplified very well, but who cares? When I'm grading your stuff, I don't care so much about whether you simplify it. I care about whether you write it in a way that's readable, that me or anyone else reading it can sort of understand what it is you've written and maybe a little bit how you got what you've written. Those are the two things you just turned in your homework. But so I'll be a little lenient here for the first homework, but in the future, when we do more and more homeworks, it's not that I want you to like, oh, here's a 1/2 and a 1/2. You should have made that a 1/4. So I'm going to take off points. I'm not going to do stuff like that. That's dumb. That's petty. But what I do want is for you as the student to demonstrate some understanding of this material by showing me how you got your answer, just in some form. And the way you leave your answer, actually my suggestion to you is leave it in the way that is the most clear to me or anyone reading it, what your answer is and how you got it. Like, so in this case, I might just leave it here. Like, okay, that's dy dg zero. It was hard, but I think it was possible. I told you guys what the power rule is, what the chain rule is. It's just a repeated application of that. Notice that there are I zeros in here. So the comparative static dy dg zero, which if we go back to like our economics intuition or our economics, what's the word where this is where it comes from. It comes from an economic model. Origin, perhaps, is that as G0, which is government spending, G0 is government spending, as that increases, so you increase government spending by $1, what happens to the national output? That's Y. This answer tells you, it says, well, it goes up at least by 1/2. So like, 50 cents of the dollar goes right back into what the economy produces. But you also have this term, which is kind of complicated and actually depends on what I and G are. Is it positive? Is it negative? I'd imagine it's positive, this second term. This has to be positive. This has to be positive. A positive number raised to any power is still positive. And this here is positive. So it's something bigger than 50 cents. The government spends $1. How much of that does the economy get back in terms of its own growth? Well, it's at least 50 cents. How much more? You'd have to evaluate that term with some specific numbers to know. But that's what this is telling you. This is the interpretation. That's the word I was looking for. The economic interpretation of this formula is a real world thing that says what happens when governments make investments in themselves. In other words, they choose to spend more money for like a stimulus. We're dealing with this right now. Did you know Joe Biden has proposed a 1.9 trillion, not billion, $1 trillion stimulus plan to help overcome the effects of COVID. So economists are the type of people who take something like that, like, well, what's going to be the real effect of this? What do people do once they get that money? Of course, they spend it in the economy. Some people might invest it. Some people might save it. Actually, people who don't need the money are probably going to save it. All of this can go into a model. What I've shown you here is just really, really simple. I will admit that. I mean, maybe you're saying, actually, it's not simple. You had all that square root stuff going on. But I mean, conceptually, it's simple. There's only 2 equations. And the equations that we started with were not that hard. These ones up there, the starting ones. But if you decide to continue with economics, what will happen is you'll get more and more complicated models. You'll actually probably need computers to solve them. They'll be so complicated that you won't bother trying to solve them by hand. You will use a computer. So why am I teaching you to solve these by hand? Because you need to have the foundation to go on. And if you want to get a master's or a PhD in economics, I want you to be able to do that. Okay. Does anybody else have any questions about the homework?
Professor,
Sure.
can you let me know what the P1 values were, or value?
What's the P1 values?
Oh, for number 2, sorry.
The P1 values for number 2.
Yeah.
Gosh. I feel like I have the answers to these somewhere. I just don't have them accessible right now. Do you want to ask other people? What did everyone else get for P1?
I got 3.14 for and negative 4.84 for the other.
Yeah, that's about what I got. I just got 0.03 difference. I got 3.17 and negative 4.87. That's
So
close.
you guys got some negative prices? I think that it shouldn't happen, but maybe I didn't tell you not to do that. So that's okay. The supply of good 1, find the equilibrium prices and quantities of good 1 and good 2. Notice the first equation is quadratic, not linear. Once again, I give you a quadratic model here. So So you actually got answers that gave you negative prices.
Yeah, I thought that was a little weird too, but I figured I'd leave it in because my Q1 and D1 were close enough to equal to each other for both of them in the same.
Was there an answer where all prices were positive?
For P1, I had both of them were positive.
But what about P2? Did you ever find a positive P2?
Oh, sorry. Yes, I got a positive P2 for the same values. I got a positive P1
Okay, so there was a solution that had both prices positive.
from what I got. Yes.
Yeah, and how about the quantities? Were the quantities positive too?
Yeah, all of my quantities were positive.
Okay, so that's actually the right answer. And I'll probably be, I'll be as lenient as I can. The other answer with the negative prices is actually, it doesn't satisfy our interpretation of this model because prices can't be negative. It's no longer a good if it has a negative price, it's a bad, and it's something you're like paying people to take away from you, like garbage. I mean, I suppose if you want to think of this is no longer the price of a good, it's the price of a bad. But I did call them goods. I said, consider an economy with exactly two goods labeled good one and good two. So if the prices become negative, they stop being goods and it stops making sense. So, the best answer here would be to just give me the ones with positive prices and positive quantities. But yeah, so 3.14 is awfully close to pi. I didn't do that on purpose. If it turns out that the price happens to be pi dollars, that's kind of funny, but interesting. And perhaps that's right. I'm looking at the demand curves right now. Their intercepts are 10 and 15. So you're probably going to want a price that's, close to $3. The supply curve, the first supply curve is quadratic. The second one is linear, but they're going to intersect. I'm just thinking in my head, where would the supply curve and demand curves intersect? I think 3 is actually pretty close to the right answer. Without having done it. Pardon?
Do you give partial credit on your homeworks? Like I'm just looking
Yes.
and some of these are like, yeah. Okay. Just want to
I will. Yeah, if you made a mistake along the way, I will look at it. And once again, this is your incentive is to make it as clear as possible to me what it is you were doing and how you did it. Because the more I can see what you did, the more partial credit I'll give you.
Yeah, that makes sense.
It could be almost all the credit if you just like made one tiny mistake right at the end and it flipped to like a plus to a minus or something. I often give people 9 out of 10 points for something like that.
I have a question. Is it possible, like, because we don't have like a bunch of time to go over all the homework, like that you post like a key after, like how you solved like the homework problems?
I think so. I mean, I just solved number 3 for you here.
Yeah.
But you want to see 1, 2, and 4 also?
Yeah, I was just like even if you could just write it out and like post it instead of like going over it in class.
Yeah. I can work on that. Let's talk about the quiz today, because I want to have our first quiz today, and it's going to be over differentiation, which is something I know I said I hope everybody had already seen it before, and this was kind of a review, but I'm just a little worried that there's some people who, even with the short review we had last class, still feels a little uncomfortable and would like to see more examples of differentiation, and I think we should do it now. Jacob Johns, is he a student? Sorry, I haven't memorized the names of all my students. No, this guy is not one of my students. Should I let him in anyway? Ask him, hey, what's up? Okay, don't have time. Let me stop showing you the answers to these homework problems, and let's give you an opportunity to ask me some questions about differentiation. If nobody has any questions, I'll just do some examples. Does anybody have any questions? I mean, so let me just take a step back. The quiz today isn't just differentiation. I'm also asking you about these sort of basic modeling principles. You know, how do you solve a model like the national income model? I think I'm going to ask you something pretty much just like that on the quiz, another one. And I'll ask you about comparative statics too. But I'm also want you to understand differentiation. Maybe let's take some time to do some more examples of differentiation. Okay. No one has any questions? Yeah. Okay. The real big things I want you to be familiar with are these rules like power rule, product rule, quotient rule, chain rule, and also how you do exponents and logs. If you know how to do those things, I think you'll be fine. The other ones I think are pretty obvious, like, you know, what do you do where there's a constant or there's a coefficient or, yeah. So let's just get a little bit more practice with that. I want you all to do very well today on the quiz. Here's an example. Which one do you want to see? Product rule, quotient rule, chain rule, or exponents or logs, or some combination of all of them? How about some
Exponents and logs.
exponents and logs? Okay. Yeah, let's start with the, I'm going to pinpoint my, was it spotlight my video. Here we go. F of x equals, let's talk about the logarithm of, that's the natural logarithm of x squared plus 1. How would I find the derivative of that? You guys tell me.
It's just 1 over x squared plus 1, and then you also find the derivative of the inside, which would be 2x times 2.
Perfect. Yeah, thank you, Colin. You guys see how we did that? Derivative of the natural log is 1 over whatever's inside the natural log, but don't forget the chain rule. You also have to add the 2x. You see this okay? It's actually looks a little blurry on my screen. Okay, I think it's all right. How about f of x equals x squared x plus 1. Okay. F of x equals x squared equals to the x plus 1. What is f prime of x? See if we can do this one just in one line also. Anybody else want to give this one a shot? You're going to have to use the product rule. The reason you have to use the product rule is because there's no way to do these two things multiplied together at the same time. That's just not possible. But you can use the product rule, which is how you can think of it however you want. Sometimes it's you think of this as u v prime plus u prime v, something like that, where u is the first term, v is the second term that's being multiplied together. Let's use that. Let's think of it that way.
Can I provide an answer or no?
Yes, please.
All right, I got 2x times e to the x plus 1 plus x squared e to the x plus 1 times 1, which is just e to the x plus
Like
1.
that?
Yeah.
Oh, sorry. Who's talking now? I gotta see. Missed it. Because I'm spotlighting the video, I can't tell who that was. I think you got the right answer, whoever you are. But
Jonathan.
Jonathan. Okay, thank you, Jonathan. Yeah. So I'm putting this on the screen, but that doesn't make sense. Okay. Right. The derivative of the first part becomes 2x. Leave this the same, plus leave the first part the same and take the derivative of the second part. Well, it just happens to be the same thing. Yeah, that's correct. So this used the product rule and the chain rule. Should we keep going? F of x equals another example. What about like 1 over x natural log, I don't know, x. Oh, you know what I think? Well, it doesn't matter. let's just 1 over x, how about this, plus, I kind of want to give you guys an example where it makes sense to use it doesn't matter. There's multiple options of what to do here. Um, but there's something where you have an exponent on the outside. You always have the opportunity to bring that 3 outside the natural log. It really won't matter though, will it? Either way, we take the derivative of this. Let me just say this happens to be equal to 1 over x plus 3 times the natural log of x minus 4, right? That 3, which is an exponent inside the natural log, can always come outside as a coefficient, as a multiplier. But you'll get the same answer either way. Let's do that. Let's demonstrate how you get the same answer either way. So the first part, I'll get f prime of x equals, what does 1 over x become? Am I tilting this? The camera tilted. F prime of x equals negative 1 over x squared, right? Because the coefficient is -1. I'm sorry, the power is -1. That comes out, and I reduce the exponent by 1, becomes -1 x squared, or x squared. Let's do this first one. We get 1 over x minus 4 cubed times, what's the derivative of the inside? 3x minus 4 squared, right? But if you think about how this cancels, this equals, I'm going to leave that part, but this square on the top and this cube on the bottom, this completely goes away. The cube goes away, and you just get 3 over x minus 4. Notice that's exactly what you've gotten if you had taken this intermediate step and taken this derivative. So I think the rules, the sort of properties of exponents and logs can help you when you're doing differentiation as well. I think we need to review those because you know what? Yeah, the quiz is going to be, I'm going to start the quiz in like 10 minutes, but let me share this thing on exponents and logs. I had it ready for you. Slideshow. Current slide. Okay. All right, guys. I don't want to spend too much time on E, but here's like one very important fact about the number E is that it's the base of continuous exponential growth. If something is growing continuously, that means the rate at which it's growing is a function, is a linear function of itself, then it's going to grow. Sorry, the formula for an expression of this variable is going to be e raised to some power. That's always true. Something with continuous instantaneous growth is going to be expressed over time as e raised to some power of time. So looking at this y, let's once again, like y is national income here. If y has constant growth rate over time, it can be expressed in the form y of t, where t is time, equals y0. That means the value of y at some time 0, times e to the rt, where r is the rate of growth. It's the growth rate. And the growth rate does depend on the unit of time chosen. So if it's if you're looking at, if t is measured in years, then of course r should be the yearly growth rate. If t is measured in days, then r should be the daily growth rate. But as long as it matches, this formula will work. Let's see, more spaces. Then the nice thing is the growth rate doesn't depend on the units chosen for y. It doesn't. It depends on time, but it doesn't depend on y. Like if you choose dollars or billions of dollars, it's the same formula. Okay, here's a problem. Write an equation for the output of an economy, yt, if t is measured in years. The economy has y equals 10 at time 0, and there is a continuous annual growth rate of 3%. What's the answer to that? Just plug in y0 equals 10. What should I plug in for r? Should I plug in 3 for r? That would be wrong. It's not 3.
Is it 0.03?
0.03, yeah. Yeah, that's it. So y equals 10 times e to raised to the power of 0.03 times t. And that is actually the formula for the output of an economy that has this property. If time were measured in months, you could say, fine, t is measured in months, but I'd have to change the growth rate to what? 0.03 divided by 12, whatever that is, would be the monthly growth rate. Okay. This is just a neat fact about exponential functions, and really it's a justification for why I insist that we know how to work with exponential functions. They come up a lot in economics because economics cares about growth, and everything that grows continuously can be expressed as e raised to some power like of time. Okay, here's some properties of exponents I've alluded to. Some of them are just notation, right? Here's how we'll write certain exponents. I think you're already familiar with all these. I don't know if I talked about this one. A to the xy is equal to a to the x to the y. Or a x divided by y is like the y-th root of a to the x. And I give you this warning, don't try to expand an exponent inside of parentheses. That would just be wrong. Here's a problem. Simplify this term to make it a single power of 10 using these properties of exponents. You want to work on that right now? What would you think? See this problem here? The term is 10 raised to the 2x plus y power divided by 100 raised to the 2y minus x power. Take this whole thing and make it a single power of 10. So it's 10 to the something. What would it be? Your answer is going to be in terms of x and y's. You want to work on that right now? I just want to make sure you guys have a some comfort with working with exponents and the sort of properties of exponents. I'll do it here on my paper too, and then we'll compare our answers. Oops. This one. That's smaller. One issue you guys might have is how do I change 100 to a 10? You should know that 100 is 10 squared. So use that fact. Does anybody have an answer? Anyone have an answer to this problem I have at the bottom of the screen? 10 to the 2x plus y over 100 to the 2y minus x. What does that equal to in terms of a single power of 10? You got to use these properties. Use the exponents properties. I'm running out of time here. Anybody got an answer? You guys look like you think you might want to say, but you don't really want to say your answer. It's okay if you don't, I guess. I'm going to give you the answer if no one is willing to volunteer what they got. How should I spotlight myself? Okay, I think I am spotlighting myself. Wait, this whole time were you looking at the PowerPoint slides or my camera?
PowerPoint.
Okay, good. So here's the answer that I got. Nobody wants to volunteer. Okay. I got this. About that. I started with 10 to the 2x plus y, and then I rewrote 100 as 10 squared. And then 100 raised to this power is like 10 squared time, where 10 raised to the power of 2 times 2y minus x. Right, the missing thing here is 100 to the 2y minus x. Y minus x. 10 to the 2x plus y. This is an x. Equals, okay. So in this step, I just changed 100 to 10 squared. But because of the rules of exponents, it's just like saying 2 times 2y minus x. That's a nice property of exponents. And then to get from here to here, I said, well, when I have 10 raised to a power divided by 10 raised to a power, it's like I'm taking the top power and subtracting the bottom power from it. For the same reason, if you had like 10 to the 4th divided by 10 to the 3rd, it would be equal to 10 to the 4 minus 3, which is 1, 10 to the 1st power. So I did that here. I got this thing, and then I combined the x's and y's, and I got this. Did anybody else get that answer too?
Wait, how did you get rid of the bottom 10 again?
How did I get rid of the bottom 10? Oh, I didn't. I just combined this numerator and this denominator into 1 power of 10, where this term was the numerator and this term was the denominator.
Oh.
And I'm subtracting, of course, I take the numerator's power and subtract the denominator's power. That's one of the rules of exponents that I was showing you. I meant to show you. Maybe I should have left it up a little longer, but it was there. This one. If you look, get smaller. This one. Oh, it's kind of going backwards here. A to the x divided by a to the y is equal to a to the x minus y. Okay? So it's not like I got rid of the y, it's there, it's being subtracted. And of course you have similar rules for logarithms, which I won't go over all of them because they are basically the same thing in reverse. But I showed you this one already. The natural log of x to the y is equal to y natural log x. That one comes in handy a surprisingly frequent amount of the time that you're dealing with some formula which is very complicated. It has a natural log in it. And because of this rule right here, the second bullet point here, I can simplify it greatly and make it something that I can take the derivative of easily or whatever. And so I recommend, please be aware of this one. Natural log of x to the y equals y times the natural log of x.
Is there any way to have solved that problem if you didn't make the 100 into 10 squared?
No, I don't think so, because I said I wanted it in a single power of 10. I don't know. Kai, can you tell why I did that? I just wanted you to use the properties of exponents. So like,
yeah, I get that. I just wasn't looking at the properties, so like.
Yeah, well, I think I left them on, but maybe not long enough. So, I could ask you a little bit about exponents on the quiz too. So ask me now if you have any questions about these properties. I think I have one question about the properties of exponents on the quiz. But it is multiple choice. That question is multiple choice, and it's open book and open note. So you can refer to any of my PowerPoint slides to work on your quiz. Of course, there is going to be a time element of it, so I just don't recommend, you get question 1 and you go through and read all my PowerPoint slides and make sure I don't say anything that contradicts your answer, and then you say, okay, fine, I've answered number 1. Now I'll go on to number 2, and 10 minutes have gone by. I hope you don't do that. That wouldn't be a good strategy for taking this quiz. I think I've given you plenty of time for the quiz. I'll plan to give you 30 minutes for the quiz. Regardless of when we start, it'll be 30 minutes from when you start. Okay, so you'll go to Blackboard and you're not looking at this right now, are you? Where is it? Under assignments, you'll see quiz 1. And then once you click on it, it'll give you this option. Okay, you want to start. Once you start, the 30 minutes will go. I have to select exactly what conditions I want the quiz to be under. I'm going to say you can't do it multiple attempts. Sorry about this. So please, once you start, kind of make sure you have a good internet connection. If something happens with your internet connection, talk to me about it. We'll try to get it fixed. But this is the kind of thing where I just want to give you the one attempt to do it. And once you start, you have to complete it. And there will be a timer of 30 minutes.
How long will you have the quiz available for?
How about an hour? Is that enough?
I have classes pretty much straight through until 4:45.
Yeah, so can you take it now?
Yeah, if we stop within the next like 10 minutes or so, I could probably have it.
No, I'm gonna make it available very, very soon. I just have to click these buttons. And then it'll be available. So you can even start getting ready to log onto Blackboard and take the quiz. Sorry, I just want to make sure I get all the right numbers correct, because then, when it's starting. Okay, I think I'm ready. I'm going to press submit, and now it should be available to you. So if you go to Blackboard, under assignments, I think it's under assignments or whatever it's called quiz 1.
Yeah, I don't see it yet under
You don't see
assignment.
it yet? Okay, let me see what's happening. Item is hidden from students. Why is it hidden from students? Okay, make available. Maybe this will make it work. How about now?
Yep, I see it.
Yeah, sorry about that. Okay, I think it's good now. So I'll stick around, and if you have any questions, you should ask me privately in chat, and I will do my best to answer your question.